Elastic and inelastic collisions. Elastic collision is one in which the kinetic energy of the objects before the collision and the kinetic energy of the objects after the collision is the same, or not only is momentum conserved, but kinetic energy is conserved as well. Elastic collisions don't typically happen with large objects, but are common with small particles like you might see if atoms were colliding or something like that. An inelastic collision is a collision where kinetic energy after the collision is less than it was before the collision. So some of the kinetic energy possessed by the objects in the initial stage is lost to other forms of energy in an inelastic collision. Finally, a completely inelastic collision is a collision in which the kinetic energy of the objects is as low as possible after the collision. If we recall Hooke's law, and we recall that the force in the stretch of a object at first is linear, and that we called this the elastic region, then we can see a connection to these words. If collisions occur such that all of the forces remain in the elastic region for the molecules, then we're likely to have a pretty elastic collision. On the other hand, if we go into the inelastic range, this is the range in which the force is causing permanent deformation of the objects. Then what we have is we have kinetic energy being converted into changing the materials in the collision. So if you stretch a spring with a low enough force and it stays within the elastic region, when the spring is unstretched it will be the exact same. But if you apply too large of a force and you cause the spring to move out of the elastic region and up into this inelastic region right here, then what you're going to see is that the deformation of the materials will cause that, or will be permanent, such that when that force is removed, the materials will never go back. When that happens, the objects involved in the collision will change their kinetic energy into other forms of energy, and as a result, the kinetic energy before will not be the same as the kinetic energy after. A completely inelastic collision occurs when two objects that are colliding with each other stick together to form one large object after the collision. So in a completely inelastic collision, the two objects stick together. Okay, so what I'm going to do now is I'm going to do three examples. I'll do an example with a completely inelastic collision, I'll do an example with a completely elastic collision, and then I'll do an example where energy is being introduced into the system. So let's start with the completely inelastic. Let's just give ourselves a little more space by doing that. Two cars collide in an intersection. Car A has a mass of 1,560 kilograms and an initial velocity of 65 kilometers per hour north. Car B has a mass of 1,250 kilograms and an initial velocity of 75 kilometers per hour. The collision is completely inelastic, which means the cars crumple together. Determine the final velocity of the cars crumpled together. So, this is a problem that I'm going to have to do separately in the north and east direction. In the north direction, I have mass A, 1,560 kilograms, V1A, given to me as 65 kilometers per hour. I don't actually have to do this for this example, but I'm going to convert this to meters per second just because it's sort of typically what I do here. In this particular example, you could get away with leaving it, but I'm not going to. I'm just going to make the change. I have my mass B of my vehicle, which will be 1,250 kilograms, and V1 of that vehicle, which in the north direction, since it's going straight east, is 0. So, P1 is equal to P2, or the momentum before is equal to the momentum after. MA, V1A, plus MB, V1B, those are my momentums before, are going to be equal to M total, V2 total. Because this is a completely inelastic collision, the cars are crumpling together, so I'll treat them as one object in the final state. So 1,560 kilograms times velocity A, which is 18.1, plus 1,250 times 0 equals 1,560 plus 1,250 times the velocity of t, found 2t, so if I multiply those out, and then I make this addition over here, this is kilogram meters per second, 1,560 plus 1,250, 2,810 kilograms, V2T. Now solving, V2T is going to be 10 meters per second. Okay. In the east direction, I have my mass A, which is 1,560 kilograms. My V1A, keeping in mind that it was going straight north, and then the east direction it wasn't moving at all. Mass 2, 1,250 kilograms. V1, or mass B, sorry. Velocity 1B, 75 kilometers per hour. I'm going to change that to meters per second. Try that again. 20.8, and my mass total, and so I don't know anything about my final, so basically the same equation here. Momentum initial equals momentum final. Mass of A, V1A, plus mass of B, V1B, that's my total initial momentums, is equal to mass total, because they crumple together, velocity total, which works out to be 0 plus 1,250 kilograms, 20.8 meters per second. The mass total, 1,560 plus 1,250, and the velocity total. So I can just solve that directly. That's going to be 9.25 meters per second. Now, that means I'm going 10 meters per second north and 9.25 east. So I can find my final velocity. Using Pythagorean theorem. There's my theta. Tan theta is equal to 9.25 divided by 10. 42.8 degrees. So north 42.8 degrees east. So when the cars, this one came into the intersection like this one came in like this, they crumple together as one big object, and they come out at 13.6 meters per second, north 42.8 degrees east. Okay, I'm going to pause the video here. I'll do the next couple examples in a different video just to keep the time of those videos short. So, elastic collisions, when the kinetic energy is conserved, all the forces remain in the elastic region, so none of the energy gets transformed into deforming the materials. Inelastic, if we extend into this range, there's deformation of the objects, and so the kinetic energy after the collision is less than before. And completely inelastic, you go so far into this elastic region or inelastic region that the two objects stick together, and that's going to get you your lowest final kinetic energy. And so if you see the words completely inelastic in a question, what you know then is that the two objects in the final state are going to stick together.